In last class we have seen confidence intervals. Today we will see basic concepts which are related to hypothesis testing and statistical significance, which is used in hypothesis testing. Let's see what is hypothesis. In English, hypothesis means an idea or explanation for something that is based on known facts but not yet been proved. In statistics, we define hypothesis as an assumption about the certain characteristic of population. It is often stated in terms of population parameters such as mean and proportions. Hypothesis testing. Statistical hypothesis test is a method of statistical inference. It evaluates two mutually exclusive statements about population to determine which statement is best supported by sample data. Means based on sample data, we will infer about the population parameter. Hypothesis testing can be done in two ways. One, significance testing, and another way by using confidence intervals. Significance-based hypothesis testing is most commonly used statistical hypothesis testing. To discuss hypothesis testing, we need some basic concepts. First, we need to properly formulate null and alternate hypothesis. And based on hypothesis, we need to decide whether it is one-tail or two-tail test. So let's see how to formulate null and alternate hypothesis. Suppose in particular region, in reading test, mean score is 100 points and standard deviation is 12 points. In particular school, the mean score of 55 students observed as 96. We want to test whether this mean score is significantly lower than the regional mean. In other way, we can say that the students in this school comparable to the region students or their scores are surprisingly lower than a regional student mean scores. Here we don't have all the scores of that school students. We have only scores of some sample of size 55. Based on this sample, we need to estimate that entire school student scores, whether that is equal to regional students mean score. Because we are using sample, here we don't have population mean score of that entire school. We have some sample mean score, that is 96. This is lower than this regional mean. There are two possibilities. Error might be because of sampling bias, means in that 55 student sample, more below average students are included. If you take average of all student scores in that school, it might be greater than or equal to the regional mean score. And second one is the school students are really below average. To test that, there are two hypotheses that are made, one null hypothesis and another one alternate hypothesis. Null hypothesis is usually hypothesis of equality between population parameters. Null hypothesis states that there is no difference between population parameters. Null hypothesis is denoted with H0. Here our null hypothesis is mu greater than or equal to 100. Because null hypothesis will not assume any difference between the two populations. One is the school students mean and regional students mean. Regional students mean is 100. See our hypothesis statement. The students in the school comparable to the region students are their scores surprisingly low. Means if their scores are greater than 100, they can be comparable with the regional students. So means if mu greater than or equal to 100, this mu represents the population mean of that entire school. If this is greater than or equal to 100, then it is saying that the school students are having same mean score with regional students, but not lower scores than regional students. Alternate hypothesis is opposite of null hypothesis. Alternate hypothesis states that there is difference between population means. They are mutually exclusive, only one can be true. One of the two hypotheses will always be true. Alternate hypothesis will be denoted with H1. Here, alternate hypothesis will claim there is some difference between two population parameters. This school students mean differ from the regional mean. means the school student scores are lower than regional mean. So mu less than 100. The school students have an unusually low mean scores from the region students. There are different types of hypothesis tests, one-tail test and two-tail test. In one-tail test, we have two tests, a left-tail test and a right-tail test. One-tail test is a statistical test in which rejection region will be on one side of the distribution, like this, either in left tail or it might be on the right tail. Similarly, two-tail test is a statistical test in which the rejection region will be on two sides of distribution. Here, rejection region will be two sides. Let's see some examples for this one-tail and two-tail test. The school principal wants to test if it is true that teachers say the high school juniors use the computer on an average 3.2 hours per day. Here, the teacher's statement is high school juniors will use computer on an average 3.2 hours a day. Based on this statement, let's try to frame the null and alternate hypothesis and find the which test it is, either one-tail or two-tail test. Here, teacher is saying that high school juniors use computer on an average 3.2 hours a day. School principal wants to test whether it is different or same. Null hypothesis has to say that there is no difference with known fact, that is mu equal to 3.2 hours. So this will be the null hypothesis, and alternate hypothesis will be mu not equal to 3.2. Means if less than this 3.2 also will differ with this statement, or greater than this 3.2 also differ with this statement. So rejection region for this null hypothesis will be on two tails. So it is two-tail test. Let's see another example. A researcher claims that Indian men are on an average more than 10 kg heavier than women. Women average weight is 55 kg. Then frame the null hypothesis and alternate hypothesis. Here women weight is 55 and men are 10 kg more, it is 65. Here researcher is stating that men are 10 kgs more heavier than women. Women weight is 55, so men's weight will be 55 plus 10 more than this 65. This 65 is the mu naught. Here researcher is claiming that men weight is more than this, so mu greater than 65. It is claiming the difference, so this statement should be alternate hypothesis, and null hypothesis will be mu less than or equal to 65. Because here if null hypothesis is assuming all less values than this 65, so rejection region will be on right side, means more than value 65. Deodorant brand claims that their deodorant fragrance stays more than 24 hours. Let's frame the null hypothesis and alternate hypothesis. Every company try to project that their brand is performing better than average. Suppose this is the average values. They are trying to claim that their brand is performing better than this standard value 24. They are differing with this standard value. So alternate hypothesis will be mu greater than 24, and its opposite statement null hypothesis will be mu less than or equal to 24. This mu will take values less than this 24, means if values greater than this 24 will leads to rejection of this null hypothesis. So rejection region will be on the right tail. So it is right tail test. We have seen this problem already. Particular geographic region test score mean is 100 points and standard deviation 12 points. In particular school, a sample of 55 students, reading scores are 96. We need to test whether this school students average score lower than this region average. Here, null hypothesis will assume that these school students and the population region students mean is same. Observe the statement. We need to test whether this school students score lower than the regional mean. Means this estimated population mean for the school lower than the 100. Means this is the statement claiming the difference. So it will be alternate hypothesis, and null hypothesis will tell that this school students mean either equal to regional students or greater than the regional students. Even if their test scores greater than the regional students, we cannot say that the school students scores are low. Null hypothesis will be mu greater than or equal to 100. So from the 100 and more than 100 is acceptable in this null hypothesis. If any value which is lower than the 100 will be lead to rejection of the null hypothesis. Rejection will be on the left tail. So this one is left tail test. The average salary of computer science and electronics students is different. Means this statement is saying that this computer science students average salary different from the electronic students average salary, but null hypothesis will not claim any difference between the population means. So if population mean of CSE students is mu CSE and ECE students average is mu ECE, then null hypothesis will be average value of the CSE students will be equal to average value of ECE students, and alternate hypothesis will be opposite of this statement. So alternate hypothesis will be average salary of this CSE students not equal to average salary of ECE students. Here, if this CSE student salary less than or greater than ECE students, then you will reject this null hypothesis. Means rejection will be on two tails. Means greater than this ECE students or less than this ECE students will leads to rejection of this null hypothesis. So it is two-tail test. Similarly, more men experience heart attack than women. Here, mean value of men who experience the heart attack is equal to the mean value of women. That is the means. There is no difference between these two population means. This is the null hypothesis, and there is difference between this mean value of men and women. It is the alternate hypothesis. So if not equal to there in the alternate hypothesis, then you can say that it is two-tail test. If less than is there in the alternate hypothesis, then it is left tail test. If greater than symbol is there in alternate hypothesis, it is the right tail test.